Hey everybody, this is Gregory from Dapp University. So welcome back to this multi-part tutorial series where I'm showing you how to build a real-world Crowdsael that can be deployed to the main Ethereum network in order to raise funds in ICO. In the last video, we built this basic Crowdsael and wrote some tests to ensure that it worked the way we expect. And in this video, we're going to turn this into a minted Crowdsael. So check out that previous video if you haven't already, and be sure to subscribe to the channel to see the next videos in the playlist as they come out. This episode is presented by QuickNode, the fastest and easiest way to run your own Ethereum node. QuickNode lets you run a personal cloud-based Ethereum node in a flash without having to download any blockchain data or keep it in sync. Sign up at quicknode.io today to start running your own Ethereum node in no time. All right, so in this video, we're going to turn this Crowdsael into a minted Crowdsael because, our token that we built is a mintable token. And what that means is that we can basically create tokens kind of at will. So instead of having a fixed total supply, like a lot of ERC20 tokens have, this is going to have a total supply that's going to change whenever we mint the tokens. And now don't worry, whenever we finish the Crowdsael, we won't be able to mint any more tokens. We don't want to have a token that, an admin can just willy-nilly mint whenever they want to, because that would change the dynamic of the token economics, and we don't want to do that. So what we want to do, though, is basically anytime someone purchases a token in the Crowdsael, we want to mint this token. And then the total number of tokens, is going to be affected by the number of tokens that are actually purchased in the Crowdsael. So we can make this a minted Crowdsael by going to the OpenZeppelin library and looking for the minted Crowdsael contract. We can import it like this. We can pull that up. So this is the minted Crowdsael in the OpenZeppelin Solidity library. So basically you can see that it's a Crowdsael, and essentially what it's going to do is have some special behavior. So Crowdsael, it's got some special behavior where if you look inside this basic Crowdsael function, this buy tokens function, this process purchase function, we see that here. Inside of there, we actually deliver tokens. Let's see here. Deliver tokens. And it's going to override this. So normally we would just transfer the token from one account to another. But inside the minted Crowdsael, it's actually going to mint the amount of tokens that are created whenever this buy tokens function is called. So in order to get that behavior, we can just, pull in this contract like this, and we can inherit from minted Crowdsael. All right. Excuse me, save that. Now, I don't think we need any new constructor arguments, so we can leave that as is. And let's go ahead and just try to compile the contract to make sure it works. All right, that worked. And now let's go ahead and run the tests. Let's just see if they still work. They should work just fine. All right, there we go. So I'll clear that. And now before we continue, we need a couple things in order to start writing tests against this. And it's a few kind of dependencies that I didn't pull in up to this point. So what we actually want to do, is pull in some external libraries, and we want to configure this test so that we can use ES6 imports into this file. So what that's going to look like is we want to require files ES6 like this, import, and we need some special configuration in order to do that inside this project. And we also want to use some special chai assertions. So we want to also add, excuse me, some libraries there to our package.json. So let's go ahead and do that. So inside our package.json file, I want to add some of these Babel configuration libraries into the project, like this. Basically, I'm adding Babel polyfill, and then these Babel presets that we specified earlier in our Babel RC file. And you can just copy these from the repository whenever I deploy this. And I also want to import below chai. I want to do chai as promised, which is going to allow us to just check for the return value of promises whenever we write these tests. So I'm going to save these and go ahead and run npm install. All right. And now what I want to do is also go to the truffle.js file. And because this is the entry point for our project, I want to add some requirements here so that we can use those ES6 imports like this. So basically, I just installed Babel register and Babel polyfill, and I'm going to go ahead and require them inside of this truffle.js file so that we can use ES6 module imports in our tests. So I'm going to run the tests again, make sure everything works. All right, that works. So let's go back to our test and let's try to write a test that basically says that this Crowdsael can purchase tokens, because that's what's actually going to happen whenever we mint tokens. So let's write a test that says that let's just describe. We'll just make sure that token purchasing actually works. We'll say accept payments, and we'll pass this a function. All right. And inside of here, I'll say it should accept payments. And I'll do an async function here. All right. And now what I want to do is say, wait, this Crowdsael. And I'm just going to send this Crowdsael some ether, which is going to call the buy tokens function. So I'll say send transaction. And I'm going to pass it, value, the amount of ether we want to send. And I'm going to pass it from who we want to send it from. So in the from field, what I want to do is actually start using some investors in this testing scenario. So up here, when we're importing the accounts, I actually want to specify some new accounts. I'll say investor 1 and investor 2. We'll use those for different scenarios. So inside of here, I'll say this particular test is from investor 1. Oops, investor 1. All right, and the value is going to be a variable that I fill in here. Okay, and I'll say const value. I'll fill this in. Now what I want to do is basically just send, 1 ether to this contract, and I expect it to basically work. I expect it to purchase tokens for me, and I expect them to be minted in the minted Crowdsael. So I want to fill out this value. In order to do that, I'm actually going to bring in a helper that I like to use that I pulled from the OpenZeppelin Solidity project. I'm going to create a new file. It's going to be an ether helper. So basically, we're going to pass it a number, and it's going to return that amount of ether in way expressed as a big number that we can use for testing. So I'm going to create a new file inside of here called helpers. This will be called ether.js. All right, so test helpers ether.js. And I'm just going to paste in this helper like this. All right, and what's going to do is, this is why we needed to use all those Babel dependencies that I just pulled in, so we can use ES6 module imports and exports. So what it's going to do is have a default export. It's going to be a function called ether. And this is going to just say whatever value you pass in, like if it's 1, it's going to convert it to way, and it's going to return a big number. So I can import that into this test like this. Import ether from helpers/ether. And what I want to do is set the value here like this. Say ether 1. And that's pretty nice. Makes this nice and easy. So I'm going to go ahead and run this test, and it's probably going to fail, and I'll tell you why. Let's just see. All right. So this actually experienced through an exception, and I'll show you why. So inside the Crowdsael, we can kind of trace back what's happening in the purchase tokens. Let's see, minted Crowdsael. What we can do is, now on this side of the deliver tokens function, we said that we're going to get a reference to mintable token, and we're going to call the mint function on it. So let's see what happens inside of the mintable token whenever minting is called. So whenever we mint, it's going to have the to address and the amount. And we can see, this is what happens when it mints. It increases the total supply, and the balances are changed, and it emits some events. But there's some function modifiers on here. Has mint permission and can mint. And so what do those mean? Let's take a look. So can mint. Is minting finished? Well, in our case, minting is not finished, so that's okay. And has mint permission. Now, what does that mean? So msg.sender, whoever's calling this function, must be the owner. And if you look at this contract, it's an ownable contract. So if you haven't seen this before, ownable is basically a contract that says it basically specifies the owner of the contract. And by default, owner is msg.sender. And in our test, msg.sender in this case is the address that deployed this contract. So what we want to do is, in order to mint these tokens successfully, we have to transfer the ownership. And the reason this reverted was whenever we try to say, mint this token, it says, I won't let you mint this token because you're not the owner. Well, who's trying to do it? It's not me. It's not the account that deployed it. It's the Crowdsael. It's actually the Crowdsael that's trying to mint these tokens. So the Crowdsael itself actually has to have ownership of this token in order to mint them successfully. So how do we do that? Well, we have to transfer the ownership of the token to the Crowdsael after it's deployed. And we're actually going to do that in this before each function in our test. So I'm going to just paste this in here. After it's deployed, we'll wait for it to be deployed. And then we say this.token.transfer ownership, this.crowdsael.address. And we can see ownable. We can see this transfer ownership function, transfer ownership, new owner, and only the owner can do this. And so inside my tests, inside my tests, I'm the owner calling this basically. It's the implied from value. And I'm, saying Crowdsael, now you're the owner. So I'll save that. Let's see if it works. All right, it passes. Awesome. So now that we've transferred the ownership, I also want to test another, part of accepting payments. What I want to do is show you something about this Crowdsael. It's another feature. So whenever we buy tokens, let's say just Crowdsael, we can we can call this, we can either send Ether to the smart contract directly, right? And that just says buy tokens on behalf of whoever sent the Ether, right? It's going to trigger this function. But we can also buy tokens on behalf of somebody else. Like, there's nothing stopping us from doing that. If you gave me your address, I could call this buy tokens function and buy them for you and make you the beneficiary. So we just want to add a basic sanity test to ensure that our contract can do that as well. So I'll go to this, and I'll say const purchaser equals investor2. All right. Oh, actually, hold on. I'm getting ahead of myself. Before I do that, I need to use this library that we imported, into our package.json file. I'm going to paste it here. So we're going to use require chai as promised. And we actually want to ensure that this works. Sorry, I meant to do this when our test was passing. So we can check to see that this promise is actually just fulfilled and that there weren't any errors whenever we sent Ether to this smart contract like this. We can say basically should be fulfilled. All right, now let's run that and make sure that that works. All right, there we go. All right, so back to what I was saying a second ago. We want to test that this Crowdsael can purchase tokens on behalf of someone else. So yeah, I'll store purchaser as investor2, which comes from here. And what I'll say is await this.crowdsael buy tokens. Oops. And what I'll do is I'll buy them on behalf of investor1. And I'll say from. We'll do the value, actually. We'll just say the same value. So from purchaser, which is investor2. And this also should be fulfilled. All right, let's run that test and make sure it works. Okay, awesome. So the next thing I want to do is basically test the core functionality of the minted Crowdsael, which is to say that the total supply of the tokens is actually going to increase whenever we purchase tokens. And I'll show you how to do that. So we'll say describe minted Crowdsael. And I'll pass this function. All right, and I'll say it mints tokens after purchase. Say async function. All right. And now what I'll do is say const original total supply. Say await this.token total supply. Oops. Sorry. All right. So I'll save that. What we're going to do is basically compare that the original total supply is less than the new total supply. So that like whenever we purchase tokens, that the total supply of the token actually increased. Because that's what's happening in the minted Crowdsael. It's minting tokens every time we purchase them. So now I'll say await this.crowdsael. Send transaction, just like we did here. And I'll say, value, say ether. Let's do 1 ether. And let's say from investor1. All right, so we've transferred this. And now I'm going to say const new total supply is equal to await this.token.total supply. All right. And now we'll do is just say assert that, we'll say assert is true, that the new total supply is greater than the original total supply. And basically, if that's true, then tokens were minted in this purchase. So let's run the test, see what happens. See if I made any errors. I might have. All right, looks like I did make an error. Let's see what happened. So, oh, sorry. I just made a dumb mistake. I did a wait dot. Yeah, you probably saw that coming before I did. It's a syntax error. All right, the test passed. So let's just ensure that this test is valid. Let's just, say original total, we'll say new total supply is like 0. All right, so go back and it works. All right, there we go. So now we have a mintable Crowdsael, or a minted Crowdsael, that's going to actually mint tokens anytime someone purchases this token in the Crowdsael, and we've got a test that ensures that it's working properly. So that's it for today, guys. I hope you enjoyed the video, and be sure to subscribe to the channel to see the next video in the playlist when it comes out. And until next time, thanks for watching Dapp University.